Hi everybody, we are going to be working on similarity. And this is kind of different than congruency. So I want to kind of do a compare and contrast between similarity and congruency. So, congruency versus similarity. They have different symbols. Congruent has the equal sign with the little tilde on top of it. Similarity, or similar, if two shapes are similar, they just have this. They lose the equal sign. So that's the first big difference. Well, that's not really a big difference. It's a cosmetic difference. It's just a different symbol. Congruency, we kind of learned it as same size, same shape. Similarity is same shape, different size, and sides, the lengths, are proportional. So like I said, this is just a really quick one, just to kind of refresh the memory on that. Here's an example. If you have a triangle where you have 2, 3, 4, and then you have an even bigger triangle where it goes 4, 6, 8. And if these two triangles are similar, we'll call this A, B, C, and then D, E, F. Now, we'd say AB divided by the corresponding side here. Since this is the smallest side and this is the smallest side, DE. Those two lengths are going to have to be equal to the medium sides, AC divided by DF. So those are the medium sides. The largest side here is BC divided by the largest side here, which is EF. So let's go ahead and replace the numbers. So we get 2 divided by 4. That should be equal to 3 divided by 6. And that should be equal to 4 divided by 8. If these two triangles, which I drew absolutely terrible, if they're similar, then all these three have to be equal. So you can use a calculator, or you can use however you want to, in order to make sure that these proportions are equal. You can simplify them, and it'll be equal 1/2 is equal to 1/2 is equal to 1/2. So all three sides are proportional. So therefore, I can say that triangle ABC is similar to triangle DEF. They're not congruent. Let me move that up a little bit. Triangle ABC is not congruent to triangle DEF because the side lengths are different. So we're going to use this idea of proportionality all over the place. I know you dealt with this in 7th, 8th grade, 6th, 7th, 8th grade, but proportionality, believe it or not, is one of the big things that we do here. And this ties in to dilations, which we also have kind of talked about a little bit. So we could have actually figured this out, do some rotation, and make everything all nice and neat. and we could have found out that this triangle DEF is actually a dilation of triangle ABC if we transformed things, if we rotated them and translated them and made them all nice and lined them up. So we could, because this is exactly 2 times the size of this. So that's similarity in a nutshell.